Hi gang, so today we're going to start talking about data analysis. Sorry, I'm getting over bronchitis a little bit still. This is where we take our information, our data we've recovered, and we put it into meaning, scientific meaning, which we've been talking a lot about lately. We talked about qualitative ethnographic measures and how we can observe our users to see what tasks they're doing to get to their goals. Well, today we're going to start finding a way to put this to meaning for them. If we think about data analysis, what it really means is we have data, these binary codes we've dealt with, or numbers and digits as zeros and ones. When you start putting them together and categorizing them, they start forming patterns or themes or things we can see and visualize that create our information of today. Just like when we translate a conversation, if we're speaking the same language, English to English, Spanish to Spanish, we can understand and put these interpreted symbols, letters, words together, which is data, and form information and give it meaning. And then we can take that meaning and further that into an actual conclusion to do something to reach a goal or a task. This is the process of analysis. So the goal of analysis is really first to identify patterns and themes in the data, the numbers. If it's quantitative, we might be using scales, like the Likert scale we talked about, I'll point out again, or we might be using patterns and frequencies. So it's a method to analyze the patterns, to analyze numerical values, ratios, averages, and percentages, and put meaning into this uncategorized material. Essentially, it could be anything as easy as a click of a mouse. How many times? How many times does I click with my right hand? How many times do I stop? How long do I stop? These are all ways to collect data, but it doesn't have any meaning to us until we associate that. And we put that association into qualifiers or patterns or themes, and we start looking for this to uncover this in data analysis. The essential two forms that we will deal with, because we're not really going to get into mixed method, which is using both, but we can. But for our duration, we're going to work strictly kind of on qualitative or quantitative. It'll be enough. The qualitative, which we've talked about last week, was the ethnographic, the interviews, the focus groups, the observations of a user, which we're going to be doing throughout this, to where you learn to watch for behavioral and environmental patterns, also about tasks that the users are doing. The quantitative comes from or derives from Likert scales, surveys, those questionnaires, the dry, boring things. They don't give us the environmental context or the meaning behind stressors that we see in observations or actually communicating in words. But it's more difficult to learn qualitative because you actually have to find a way to quantify the qualitative. And we do that through a series of different measures. Well, number one, the easiest, is we make them into numbers. Numbers are malleable. When I say that, it means they can be transformed for arguments. They can be shunned either way. One person can see it as one outlier means there's no problems. One person can see that one outlier number of an 8, say, or whatever the number might be, and when everything else is a 2, is a gigantic problem. So they're malleable. They can be interpreted in different ways. And the way we interpret these numbers is the way we're going to actually take our users into understanding about what it means. The qualitative analysis can be quantified again. We can think about frequencies. We can watch how many times a person clicks a mouse. We can watch how many times they ask a question. They make remarks on how they like something, dislike something. Those can all be counted. How many yeses, how many nos? How long was it between a gesture or a thought? Did they have a pause for 2 minutes? Did they have another pause for 2 minutes? Did this one last less? That tells us something. It tells us that they're learning, that they're understanding, or their behaviors are changing, or they're too frustrated. Maybe they just quit. Behavioral actions can be accounted for. We can see it in facial stresses, frowns, anxiety, happy, sad, blinks, squints of an eye, smacks on a keyboard, ECS buttons hits, mouse taps, right clicks. All these are things that you will categorize when you start doing your actual UTA, user task analysis exams, and things you'll have to think about. If you see your user rubbing your forehead or his forehead, what does that signify? Well, usually that means I don't understand, or frustration, or if they're looking down or looking up, or they look happy. These are all things you're going to have to find a way to codify. and maybe you make a code book that says happy gesture, bad gesture, blink, frustration, and every time there's one you make a check mark in the column. So we can infinitely make these into numbers. And when you get these into numbers, there's 3 different ways to look at this. First, there's the means. It's kind of the average. It's when you take all the figures and divide them up by the total number. That's what we always usually think of the average number. But another association is the middle, which sometimes is more interesting because it might be the middle number of values. If you add them all up and then rank them, you can get the middle value to say sometimes more significance than the average. The mode, which is the most common thing, if we have a series like in this one, 2, 3, 4, 6, 6, 7, 7, 8, obviously, we see 7 the most, 3 times, so that's the mode, the most occurring number. And that might say something too, that more users click this amount of times or this many, because maybe the 2 or 3 people were more experienced and the numbers higher were less, and the average amount it takes then, and the mode of occurring is 7. So that tells your user something interesting as well. Another way we're going to work on this, and you see some examples in your book and text, is simple visual analysis. These really help you and I, or the common person. They transform data into the rows and columns, and we can use simple software such as Excel or SPSS. They'll graphically represent the material. Everybody knows what a pie chart looks like. It's a simple way to look at 2 different things, or bar graphs are fun because they show a very easy understanding about what's low and what is high. Scattered charts represent the outliers. If we have a whole group right in the center, and we have one over here, that's called an outlier. And those outliers are usually signals for something happening, or maybe some frustration, or there's a pocket of errors, or something that's so extraordinary we need to look at that measure and maybe incorporate it to get it back in with everything else. Visuals give meanings to the readers and users. They're more a friendly device from the scientific numbers. Everybody can say 8 or 12, but when you put them in a pie chart and it says 8 people like it over top of 2, it starts giving a visual representation saying, okay, we should go with the 8 people instead of the 2. So it's analyzing through externalities as well, looking for the odd things that might need to be changed. Analyzing for the groupings of thoughts and the mindsets. When we have a strong amount of people in a pie graph that is 80% to the yes and the rest are no at 20, you obviously want to shun with the 80%. So qualitative analysis can also be quantified through software, which you don't really need to do this, but it's interesting because a software called NVivo helps visualize these interviews and observations where you type up everything and all your actions and you put them into software, and allows you to make a code book. And it sees the themes and patterns almost instantly, which transforms them into your bar graphs. But more importantly, it helps you to demonstrate patterns and behaviors and actions. It's a conversational way to make interesting conversations into numbers instead of numbers into conversations, which we try to do with the quantified style, or quantitative representations of data. It also finds an easy way to represent the outliers, and you can see different frequencies in them. So it might be something some of you might want to look at. You can look at this program. It's usually a free copy for students. You don't need to do it. Or Deduce is another one on the web, which is downloadable for free. But we're going to be more concerned about the findings. Once we get this material into groups, and we find what the outliers are and the themes, we're going to be looking for patterns. That way we can suggest to our group and our people positive suggestions about what they want to do to get to their goals. It's all about making sure the tasks are done to reach the goals for our users. Then we get the fun part, the conclusions. It's all based on this data and this number. We're looking for the distributed middle ground that allows a conversation with our users so that we can teach them to make them understand better ways to reach their goals through the tasks. We're furthering research as well as we're doing this, because once you're done, you usually start it over again. We also sometimes create a paradox to where we talked before about this is something a riffle, where that externality is so different, it has a meaning that we need to keep studying. And it's also a great way to confirm our past research or our past ideas. Instead of just having an interface design saying we think it's going to work, Now we have a way to say we know it's going to work, because the majority of our findings and our data points to the fact that more people are going to enjoy this method while searching the web, while writing this code, while using this secure time. This is how science is really helping us in our world as coders. We're looking to report the findings, and that's what we're going to start doing now. And we're going to start moving towards this in our classes together. And we're going to look to find a way to use science to help coders and designers explain data to users. We want it to give meaning to your process so that when we represent something to our clients, they know that it's not just our feelings, but it's science, it's numbers, it's meaning, it's what the behaviors and patterns of their users are expecting and need to meet their goals and tasks. So this is a little bit of a more stringent lecture, but I want you guys to think about data analysis this week a little bit and kind of think about how you can measure something by watching something. Maybe you watch your little brother or sister and see how many times they pick up their left fork or right with their right hand, or see how many times they use a spoon versus a fork while at dinner, and see what you can find in frequencies out of common everyday life and observations. Maybe you count how many times the shoes are placed in a hallway or put away. All these things have meanings and can come to a different way of taking data and turning it into saying something. So look for something fun this week, and I want you to count. Maybe you watched The Big Bang Theory, and I love to see the one character who comes up to the door every time and has to pound 3 times before he can ever walk into the door. That's something that's interesting. What does that mean? I hope you find something fun to study a little bit on your own this week and try to put it in your reflection notes. Have a great week, everyone.